Greetings and welcome back for the third session on dimensioning. Here I am Dr. Ilangovan, professor from the Department of Aerospace Engineering, SS College of Technology, and this video is intended for the students of second year of Aerospace Engineering. And as we already seen in the previous video, the arrangement of an indication of dimensions are shown here. We saw chain dimension, we saw the uh, parallel dimension, and we saw the combination of chain and the parallel dimension and the progressive dimension. Okay, so this we have seen. Dimensioning by coordinate also we have seen. We will now let's look at the dimensioning by coordinate for our understanding. Now this kind of thing, like there is there's a die plate which is being made, and then there are multiple holes there. So each hole have to be very important. So I have one 0 point, and with respect to this, it is easy for the machine to be positioned and then try to put the hole, the drilling machine there, and then do it. So I have a coordinate of this center point. For example, I can come here 25 and I come down here by 20, and then I'll find the center point, and then I'll have the size of the drill as dia 15. So similarly, if I have to go here, I'll have to step out from this point 65, and from this point I'll have to step out 60, and then I'll find the center point. Now this is what this enables us to use the coordinate systems. Now the next one is the by intersecting points, dimensioning of coordinates through the intersecting point. This is for arbitrary points, and the angle maybe is not considered, but if it is the entire thing, if it is inside within a coordinate system, we can always say that this point, this, and or multiple points, and then we can join all these points to find out dimensioning of coordinates of intersecting points. Okay, now points which are equidistant. For example, I have a strip, and then we have multiple 20 holes with exactly of a particular distance. So from here to here it is 15. From here to here it is 20. So what I simply put is that from here to here I can say that it is three holes with the 20 distance each. The total size will be like 60. Or I can put this diagram as four holes, and then of dia 10. This is talking about the distance or the location, and whereas this talks about the size of the hole. If the strip is very large, and I simply don't have to draw everything as per scale. What I can do is I can truncate the drawing just to show that one can really understand, and there are 9 holes, and of 20 distance each, and then the distance between the first hole and the last hole is 180 mm. Okay, so totally there are 10 holes here. So that's an easy way of repeated dimension and equidistant dimensioning. So dimensioning of common features and of machine elements goes like this. Dimensioning of circle, we put it as dia. Either I can put it as a outside, or I can put the arrows inside, or I can pull out the dimensions like this and place it horizontal. All three things are valid. I can dimension of the cylindrical part like this. I can show it in the front view, or I can show it in the side view. So both are allowed. Ensure that you dimension only once, so that if you repeat the dimension in 2 times, if you have made a change in one dimension, you will have to change the others also. So redundant dimension is not to be done. Okay, next is dimensioning of symmetrical parts which are very symmetry about it, about a center line. You can dimension it like this, or just draw one half of the part, and then you can do it, and it is understood that this line, if I take a mirror image, the distance of this edge to the other edge is dia 420. That is what it understands, and like that. We have taken a section of that, and then the section is shown by the hatched lines here. So dimensioning of holes. Okay, so dimensioning of holes is generally like this. There are through holes. There are blind holes. If it is a blind hole, it is like this. So generally, the process is by a drill. The drill has got a nose angle of 180 degree, 118 degrees. But once it machines it, this will be 120 degrees. So this is the cone that has been formed by the drilling operation, and the drill has moved up to this distance. This distance is not useful to us, and this vertical distance up to this level only is required. So someone will touch the nose here and then move it exactly by 15 distance, so that 15 plus distance, so that this distance is around that can be kept as 15 mm, the effective dimension of this one. This one is a through hole. This is a blind hole. This is a through hole. Okay, so where the holes are to be done is what is being shown here. So dimensioning of on pitch circles, if the holes are to be done on a circle, we can simply say that what is the imaginary circle that has been drawn on the circular on the center points of all the circles is called the pitch circle diameter. And for the on the pitch circle diameter, how many number of holes and how they are spaced is what is being given here. Okay, so that's it. So dimensioning of spherical object, we have already discussed this, but once again, the spherical object, this is the spherical diameter of 50, but this is a spherical diameter of 40 here, and if this is a hole, it's a dome inside, okay, and that and which has got um, a small groove here, and this is a pin with a spherical radius of 10. There's a spherical radius of 60. There's a spherical radius of around 72. Okay, or the inner one is 12, I think. Yeah. Okay, so um, so that's it. Dimensioning of radiuses and fillet radius is there. Okay, so these are the radiuses and how they have to be done. If the center point is outside the drawing, this is how it has been marked. Okay, then dimensioning of curved surface, any curved surface, if it is there, and then multiple points are taken, and then the understanding is there. This is actually like a spline, and this is how the dimensions are being done. At every point that it is being there, how it is measured and what is the point of measurement there is what is given. Okay, dimensioning of chords in arc. If it is an arc, if I have to this point to this point is called a 60, whereas if I travel on the arc, then it is written as 65, and then we put a small mark here which is called as the arc. So this is the arc distance, and it is not the this is the chordal distance, and this is the arc distance. So if I run on this line from here to here, I would have traveled 65 mm, whereas from this point to this point, the shortest distance will be 60. So that is the difference between the dimensioning of chord and then dimensioning of an arc. Okay. So next one is the dimensioning of chamfers. Chamfer dimensioning is shown here. It is like a chamfering is being done in the corner to remove the edge sharp corner at a joint at a edge. So that is being made into a small flat, and this is like 2 mm, and with a 45 degrees there's a chamfer. This is an internal chamfer. This is an external chamfer. Again here the chamfer, instead of, if it is not for 45 degrees, you may have to specify what will be the degrees here. So here they have put it as 30 degrees. Generally it is 30 degrees or 60 degrees alone. Sometimes you can specify the distance of the chamfer. This is an 8 mm and this is 6 mm. That is the chamfer. The angle is not given here. So this is how you dimension the chamfers. Okay, dimensioning of tapers, we have here dimensioning. How do we dimension tapers here? Like this is the drawing, there's a taper, and then this the included angle is given. So major diameter minus and the difference between the diameters divided by the L, you get the angle. Okay, or it is 2 tan alpha divided by 2. This is how it has been given here. Or sometimes generally we give it as at so and so distance that you travel, how much it comes down by. Okay, the ratio is given 1 is to 10. That means if I travel 10 mm, I come down by 1 mm. So that is the taper that has been given, or percentage also can be given. So different ways of measuring tapers are here, are given. One has to check and then take some extra time to understand this. Okay, dimensioning of slope. as we said that, like if I travel for L distance and this slope is B, is beta, that is what it says here. You can also have dimensioning of countersink. A countersink is, this is a countersink that is generally done by 90 degrees. Countersinks are used for screws or something to sink into the surface so that the head doesn't project out. Okay, so this is countersunk screws, and this is how it is measured. How much depth that countersink should happen, and this included angle is 90 degrees, and this distance is 3.5 mm. So we will stop here for our next chapter. Thank you very much for staying with me. Have a great day.